We're now going to talk about some more realistic operations, specifically in the medical device and diagnostics business. In this business, there are two issues that make their type of operations a little bit different. First of all, everybody thinks in terms of batches, including the regulators such as the FDA. Secondly, non-production people tend to be involved. For example, troubleshooting, technical support, customer support, quality assurance. These people don't handle product, but their input is important to the operation. For the first couple of examples, we're going to consider a factory that makes a whole range of specialist chemicals that are formulated, tested, bottled, and packed into boxes. They're made to challenging specifications in a regulated environment. Here is an outline of the product flow. We start by formulating some reagents, then we test that bulk solution. When that's okay, it goes on to be bottled, and then the bottled product is tested again, and then the tested product is then packed into boxes and shipped. That's 5 of the processes, but we're going to add 3 additional ones to do with customer support. There's technical support because these products aren't totally reliable in manufacture and they throw up odd effects sometimes. And we have quality assurance who have an overview of the whole thing. So let's see how it looks in the model view. Well, this is the summary output sheet. It looks the same as you've seen before. We've got some products, about 3 million per year, made for about $1 each. And there's a couple of things you might note from this. The response time is 108 days, which is quite long. And the reason for that is because we have 17 variants. Each one doesn't get made that often, is what's going on here. And we have customer support, which isn't one of the main process flow activities, being the most used work center. So the constraint doesn't lie on the production floor. So let's just do a couple of things. First thing we might do is take a look at technical support. They're spending a lot of effort on this product line. Let's suppose you did, say, a Six Sigma project to reduce the amount of time that they need to spend getting things right. So that saves some money. And let's say we're going to spend some of that saving to improve our responsiveness by increasing the number of batches. So I'm going to increase the number of batches by 20%. And you'll notice that all the other activities follow along. So when we start the process, everything matches. So that has the effect of still saving a little bit of money, saves some inventory, saves response time, saves lead time, and capacity is still within an acceptable level. So that is an improvement under our definition. So that's one approach. Obviously there's a lot more you could do. Let's go back, put those things where they were, and do something different. Let's suppose you don't like Six Sigma or you don't believe it's possible. So you're just going to go all out for some kind of what you might think of as a standard cost saving. Let's try and run the bottling line at the same speed with 3 people instead of 4. So that saves some money. And because we're getting a little bit nervous about customer support utilization, let's add some hours to their day so that there's a few more hours worked in that area. So we end up with a capacity utilization in customer support of 58%. It's still the most used work center. I would make the observation about this is there are sometimes you make changes that actually have no real business impact. You should ask yourself, was that worthwhile? Why did you do it? For your information, these examples are scenarios 26 and 27 from our book, Bridge of Faith for Operations.